In this lesson, I'll show you how to find the derivative of polar curves. This is question number 1. The question reads, given r is equal to 6 theta to the power of 2 plus 5 theta, we need to find dy over dx. The first thing that we have to do to answer this question is convert this equation in terms of x and y and theta. Here's what I mean. I'll take r is equal to this part of the expression and substitute it into here, into this r, where I end up with x is equal to 6 theta squared plus 5 theta, all multiplied to cosine theta. And similarly, y is equal to 6 theta squared plus 5 theta multiplied to sine theta. The reason why I'm doing this is because the derivative of this polar equation is dy over dx, which is actually equal to dy with respect to d theta over dx with respect to theta. So by finding the derivative of this equation with respect to theta and finding the derivative of this equation, I can divide one over the other. So let's go ahead and do that. Let's find the derivative of y. We end up with dy over d theta is equal to, and we'll need to use the product rule here, so I'll find the derivative of this first and multiply it to sine theta. Then I'll find the derivative of sine theta and multiply it to this factor. So the derivative of sine theta squared plus 5 theta gives us 12 theta plus 5 times sine theta plus, now finding the derivative of sine theta is easy, that's cosine theta, times this expression. We just found this part. Now, to find dx over d theta. Dx over d theta is equal to, referring back to this equation, let's start with the derivative of this factor. Once again, we have 12 theta plus 5. We'll leave this factor the way it is and multiply it to it. Plus, now we'll find the derivative of cosine theta, which is negative sine theta, multiplied to this factor, 6 theta squared plus 5 theta. Now I put this equation on top of this equation and we're done. So we have dy over dx is equal to 12 theta plus 5, and feel free to expand if you feel comfortable doing that, plus cosine theta bracket 6 theta squared plus 5 theta all over this expression. 12 theta plus 5 cosine theta minus, I'm combining the plus and minus together, sine theta times 6 theta squared plus 5 theta. And there you have it. That is how to find the derivative of polar curves.